Welcome to this football data analysis project. In this project, we're going to learn techniques used in data analysis and also in data science, such as data collection, data cleaning, and preparation to build a simple model that predicts the winner of the FIFA World Cup 2022. So first, we're going to extract football matches from all the World Cups played so far. Then we're going to extract the fixture of the World Cup 2022. And then we're going to clean all this data. Once the data is clean and transformed, we're going to build a simple model to predict the FIFA World Cup 2022. And to do this, we're going to use Python libraries such as Pandas, Selenium, and SciPy. Alright, now let's get started. In this video, I'm going to show you how to easily do web scraping using Python and Pandas. With Pandas, we can extract data from some websites like Wikipedia and do this in a couple of minutes. In this case, I'm going to extract data from the FIFA World Cup Qatar 2022 and we're going to scrape these tables that you can see here. And on the next video, I'm going to show you how to scrape data from the World Cup 1930 to 2018 and also the fixture from this coming World Cup Qatar 2022. So let's get started. Alright, to easily scrape tables from websites such as Wikipedia, what we have to do first is install pandas. So we have to write pip install pandas. If you're using Jupyter notebooks like me, you have to add this sign and then you have to run this. In my case, I already have pandas, so I can write only import pandas as PD. So this is how you do this. Then what we have to do is use a method called read HTML. So I write read underscore HTML, and then we have to write the name of the website. In this case, I already have the name of the website, but what you have to do is go to the website I had before and copy and paste. So you have to go here and copy and paste this website. So in my case, I'm just going to paste the website and it's here. All right, after we do this, I'm going to give a name to this expression. So I'm going to name it as all underscore tables. So we're going to scrape tables only and I name it all underscore tables. So I run this and now we can see the content inside this variable. So I run all underscore tables and we see that we have a lot of content. So not all of them are tables, because if we see the content here, I'm opening this square bracket 0 to see the first element. So we can see that this is a table, but this is not that table that we're looking for. We're only looking for tables from the World Cup, which is group A, B, C until H. So what we have to do here is to go and write one by one until we find the group A. So I already know that group A is the number 11. So if I write 11, we have the table of group A. So is this one. And then if we want the table of group B, we have to go until I believe is 18. So if we run this, we have the table of group B, which is this one. So we see here England, Iran, United States, Wales, and it's here. So it's the table. So you can see that we have to go every 7 tables. So 11 plus 7, 18. So 18 plus 7, 25. And we should get a table of group C, which is Argentina, Saudi Arabia, Mexico, and Poland. So it's this one. So we successfully found the pattern to get all the tables. So that's basically what we have to do to scrape all the tables of this website. So the last table that we want, I believe, is table 60, if I'm not wrong. Yeah, this is the last table, which belongs to, this one belongs to group H, I believe. So is group H. So this is the last table we want. So that's it. Now we can do some modifications to customize our tables. For example, we can change the column name, which is this one. I want this to rename as team. And also we can get rid of this table that I'm not, this column that I'm not gonna use. In this case, qualification. I'm not gonna use this column in the future for a future project. So I wanna get rid of this. And to do this, we can use a for loop. So to modify each data frame. So what I can do here is first write for I in, and then I write a range. So first we have to write the first element, which is 11, which is this one. then the last element, which is 60, and then the step. In this case, I'm going after 7 tables, so 7. So we get 11, 18, 25, and until actually it's 67 because the last one is not included. So 67 is not gonna be included, but 60. So that's it. If we print this, we see all of this. So 11 is group 8, 18 is group B, and so on. So we have this. Now I want to link each number with the table that I'm going to scrape. So for example, the first table is group A, the second is group B, and the last one is group H. So to link this number with the table, what we have to do is use another library. In this case, I'm going to use the string library. So I write a string, from string import, and now I import ASCII. So I write ASCII. In this case, I want it in uppercase, so I write underscore uppercase, and I'm going to name this as the alphabet because this actually gives me the alphabet. So I run this, and now if I copy and paste this one here, we can see that we have the alphabet, which is this one. So this is my alphabet, and this is going to help me link the letters with the numbers, and that's very good if I want to better organize my tables because this is very ugly. I don't want 11, 18, 25. That doesn't mean anything, but group A, B, and C until H actually has a meaning. So I'm gonna link them, and to do this I'm gonna use a function called zip. So if I write zip here and open parentheses, now we have to link these numbers with the letters. So I can write alphabet as my first element and then this range as the second element. Now I can write letter, and now I can print both. So letter and I. Then I run this, and as we can see, now we linked this letter with this number. So 11 is for A and 60 is for H. So we successfully linked these two. Now I'm going to clean these tables or these data frames, and then I'm going to create a dictionary. So first I'm going to clean this data frame because it has some dirty data here. So first what I'm going to do is I'm going to use these old tables. I'm going to copy and paste it here so you can see it much better. And now I'm going to use this variable. So now I write all underscore tables, and I'm going to open these square brackets and use I. So for each iteration, I'm going to get a data frame, and it's going to be, for example, data frame of group A, then of group B until group H. So I'm going to get one by one. Then I'm going to rename each column that is named team BTE. I don't want this name, I want to rename it. So I use df that rename, open these parentheses, then columns equal to, and we open these curly braces. Then I want this column name rename as team. So that's what I'm gonna do. Then I write in place equal to true. So we save all the changes that we're making here. So if we run this, we're gonna have an issue because not all the data frames have this team VTA column. If we see here, data frame 60, this one has this one, and probably 25, yeah, it has the same column, and 18. Yeah, it has. But 11, it has this weird name, which is huge. And that's gonna cause me a problem here because that data frame, which is the first one, doesn't have this name. So I'm gonna get an error saying that the column name is not there. So to avoid that issue, what I'm gonna do is use a method called columns. Actually, it's an attribute, I believe. So here I'm gonna write, I'm gonna open here and I'm gonna write, I'm gonna use the one of these data frames so you understand me much better. And I'm gonna just copy this one, for example, and write it here. Then this is my data frame, of course. Then I write columns. And if I run this, you can see that I get all the columns. Post, TMVT, PLD. I'm gonna run this here so you can see. So all of this here are here. All the letters in bold that represent the columns are in my list. So now what I can do is go to 11 and see what I get. So we see that we get all the columns, and yeah, but this looks ugly, but we see that the second element is team. And if we go to, for example, 18, we see that the second element is still team. And if we go to 60, we see that it has the same position. So what we can do is just get the second column, which is represented by this index 1. In Python, it starts the index with 0, so the second will be 1. And if we run this, we have this name of the column. So we don't have to write the name of the column, but only use this attribute, and we get the name of the column we want, independently of the name. So if we write 11, we get that one. Actually 11 here, sorry, I made a mistake. 11 here, and here 1. So yeah, this is the ugly or huge column name. So now what we have to do is just copy this and now put it here. So instead of writing this column name, I'm gonna use df that columns 1. So this represents the second column of each data frame that we have here. So group A until group H. So now I delete this, and now it's here. So now finally I'm gonna delete this column. As I said, I don't want this qualification column, so I use the pop method and write the name of this column. In this case, all the data frames have this name. I checked this before, and all of them have this column name. The name is the same. And finally, I'm gonna create that dictionary. And to do this, I have just to write an empty dictionary. So I write dict_table equal to, and I have these curly braces. So this indicates that I'm creating an empty dictionary. And then I write dict_table. And then I open these square brackets to create a new element. So for example, I want my new key, in this case, name as group A. And then this is equal to the value, which is gonna be the df. So in the first iteration, we get element A, and then we get a data frame, in this case, table A or group A. And this is gonna be in this key. And to create different keys, not only group A, but group A, B until H, we have to use this F string and then open these curly braces. So these curly braces in the F string allows me to put a variable. In this case, I'm gonna write here the letter, which is this that I obtained from the alphabet. And yeah, this is gonna help me get from A to H. So that's pretty much it. Now we can run this and see the results. So now I run this, and yeah, it's successfully run. And now I can see the content of my dictionary. So I write dict_table, and now I can use the keys method to see all the keys. So I have from group A to group H. Great. Now I can see the content of each key, in this case group A. So I write group A, and now I see the table of group A. Now if I write group B, I get the table of group B, and so on. If I change to group H, this is the table of group H. And that's how we successfully scrape all the data of this website. And also we created a dictionary to better manage all this data. Finally, one extra step that you can do in case you want to use this dictionary in a project, as I'm gonna do in this series of videos, is use the pickle library to export this dictionary. So to export this dictionary and use it in another file, we can use pickle. So we only have to write import pickle. In case you don't have it, you just have to install it with pip install pickle. In case you don't have it, I already have it installed, so I'm gonna use this one. So to do this, to export this dictionary in a file, what we have to do is write the following. We write with, then we write open, then we write the name that we want to export this file. So the name I don't know, is dict_table. You can write whatever you want, but I'm gonna name it like that. Then I write WB, which stands for write bytes, I believe. And then I write as and the name as, or the name I want to assign. So this represents, all of this represents output. And now I'm going to use pickle. So I write pickle.dump to dump all this data in my dictionary. So I write dict_table and then I write the name output here. So basically what I'm saying here is all the data that is inside this dict_table that we created, all this data, put it in this file that I'm creating. So put it inside this. And now we only have to run this and that's it. If we go to our working directory, we can see that there is a new file and it's dict_table. And that's how we export our dictionary. And that's it. That's it for this video. In the following video, I'm going to show you how to scrape the data of all the matches that are going to be played in the World Cup. So basically, we're going to get the fixture. And also, I'm going to show you how to extract all the historical data from all the World Cups from 1930 to 2018. So you can have a database of all the matches. But that's going to be on the next video. In this video, I'm going to show you how to scrape data of football matches from the FIFA World Cup. So we're going to scrape all the matches played so far from 1930 to 2018. And also we're going to scrape the fixture of the FIFA World Cup that is in Qatar, which is this one. And we're going to use Python and a library called Beautiful Soup. So let's get started. Okay, to scrape the data of football matches from all the World Cups, first we need a list with all the years that represent a World Cup. For example, from 1930 to 2018. So these are the years that had a World Cup. All right. After that, what we have to do is install the library to scrape a website. In this case, I'm going to use Beautiful Soup. And to do this, what we have to do first is install Beautiful Soup. So what we have to do is open the terminal and write pip install bs4, which represents Beautiful Soup. So we press enter and we install Beautiful Soup. And after that, what we have to do is import this library. So we write from bs4 import Beautiful Soup. So now we have Beautiful Soup. And after we do this, we have to get the link that we're going to scrape. In this case, I'm going to start with the 2014 World Cup and I'm going to paste it here. So I'm going to leave the link in the description and I'm going to give it a name, which is going to be web. So this is the website that I'm going to scrape. After this, what we have to do is send a request to this website. And to do this, we have to use the request library. So what we have to do is import requests. I'm not sure if this library comes with Python. In case it doesn't, what we have to do is open up the terminal again and write pip install requests. So we press enter and then we can continue with this. So we need requests to send requests to the website that we're going to scrape. So I'm going to copy these requests and then use the get method. So I write get and I have to write the website where I want to send my request. In this case, this website that I created the variable. So after this, when we send a request to a website, we get always a response. So I'm going to name this variable as response. And after we do this, we're gonna get a response, and we want the text of this response. So we use the text attribute to get the text of this response. So what I'm gonna do now is print this response, so you can see what this looks like. So I printed this, and what we have here is the HTML of this website. So the HTML behind this website is printed here. So if you know some HTML, you can recognize some elements like the tags and all of that, but you don't need to know HTML to scrape a website, but it helps. So after we do this, I'm gonna create a variable named content. So this content is gonna be parsed, and to parse this content, we need a parser, and we're gonna use a parser named LXML. But first, I'm gonna use this beautiful soup that we imported, and then this accepts two elements. The first one is the content, and the second one is the parser. So content and then the parser, which is LXML. This LXML we need to install. So we need to open up the terminal and write pip install and then LXML. Then press enter and you install this parser. So now I'm gonna name this as soup. This is the typical name that we use for this. And this soup is gonna help us extract data from this website. We cannot extract data if we don't have this soup. So now that I have this soup, I can start scraping this website. So basically what we did here is the common steps that we need to get started with the beautiful soup. Now we can start scraping this website. So I write soup.find. In this case, to get an element, we need to use either find or find all. The first one helps us get one element in particular, and the second one, find all, helps us get multiple elements that match the name of the tag and the class name that we're going to write in a couple of seconds. So in this case, I'm going to use find all because I want to get all the matches here. All the matches that were played in the group stage, in the knockouts, the semifinals, and the finals. So I'm gonna get multiple matches. So I'm gonna use find underscore all. And then we need to follow a syntax. But before I tell you this syntax, we need to go to the website and we need to inspect this website to see the HTML behind this website. So to do that, I have to right click and then click on inspect. So after this, we get this developer tools, and here we can see the HTML document. So this is the HTML that represents this website. And to get one specific element, what we have to do is click here on this button on the left, and then select any element that we want. All right, now to scrape a website, what we have to do is find a pattern. Every time that we want to scrape a website, we need to find a pattern that we can use in our code. So here, a pattern that I discovered is there is something with the matches, with the rows actually. So this match is inside a row. So if for example, I select Brazil here, I click on it, I get this element. But I don't want only Brazil, I want the whole row that gives me the match. So what I have to do is in this HTML document, just scroll up a little bit until I find the row that contains all the data. So I'm going to scroll up, and finally I found this row. As you can see, this element highlights all the row in blue, and that tells me that this is the row that I was looking for. So if I now click here in this arrow, I can minimize this element and I can see if there is a pattern here. So first, let's identify these the elements in this HTML element. So first we have a div, this is the tag. Then we have this item type is a class name, and then we have another class name which is class with the class the value football box. So this is one element. Let's see the next row. So we have this one. And as we can see, it has the same elements. It's exactly the same. So we have div and we have class, and then we have football box is the same. And if we scroll down, we have the same for the next match. So as we can see, these 3 rows have the same elements. So we can use this to get all the rows in this website. So we're gonna get from group A to group B, C, D, until group H, and then semifinals, knockouts, and well, the final. So we're gonna get all the matches, and that's good. So now I'm gonna show you the syntax I was talking about before. So to extract the data inside this element, we have to follow a syntax, and this syntax tells us that we need to write first the name of the tag. So here the tag, and then the name of the class. So we write class. This is a parameter, class, and then the name of the class. So let's identify this in this HTML document, or actually in this element. The tag is div. As we can see, the name is div here in blue. So here, instead of tag, I write div. And then in the class, we have to write the name of the class, which is football box. So I copy this, and then I paste it here. This is the name of the class. All right, so now we have this element that represents this row. So this is a match. So I'm gonna name this as match. But since we're gonna get all the matches, because it's gonna be like this one and this one and this one, because as you might remember, we're not using find. Find will give us only the first one, but find all gives us all of them. So find all gives me all the matches. So I'm gonna name it matches, because we're gonna get all the matches inside a list. So when we use find all, we get a list with multiple elements. Matches is a list. All right, now what we have to do is loop through this list, which is matches. So I have a list and I'm gonna loop through it. So I write for match in matches. I write the colon, and then I'm gonna extract each data that I want from this row. So in this case, I just want to get the name of the home team, which is in this case Brazil, the score, in this case 3-1, and the away team, in this case Croatia. So to do that, I'm gonna open this element with this, clicking this little arrow, I think. And then what we have to do is identify this element. So I'm gonna scroll down a little bit, and then I'm gonna identify the one that gives me the home team, which is this one, F home. So we have this element th with tag th, and then with class name F home. So this is the one I'm looking for. Then for the score is this one, F score, and for the away team is this one, F away. So we have all these elements. Now we only need to get them inside this for loop. So what I'm gonna do is write match. In this case, match represents the soup that we created before. As I told you, we cannot extract data without the soup. But since this soup is inside this matches list, we can use the match as a replacement, we can say. So this match is gonna get us all the data, or it's gonna help us get inside these elements that are here in the rows. So we're now in the rows that is here. Now we want the data inside the rows. So we're going for F home. So match dot find in this case, because I just want one element inside this row. And then I'm gonna write first the tag. In this case is th. And then I'm gonna write the name of the class, which is in this case F home. So first th, then comma, and then class underscore equal to F home. So I have now this. And now to get the text inside this element, what we have to do is use the get text function. So I'm gonna write get underscore text parentheses, and with this I have the name of Brazil. So the text inside this element is Brazil, and I'm gonna get that. So now I'm gonna duplicate this twice, and I'm gonna change the name of the class. The second one is F score and the last one is F away. So now F score and F away. Great. So now we have all these elements. And now to see the results, what we can do is print this. So I'm gonna print each of them to see the results that we have so far, to see if everything's working fine. So now I print this and now I can run it. So I right click and run this to see what we have so far. And as you can see, all these elements were printed. So we have from the first match, which was Brazil-Croatia 3-1, which is this one, until the last match, which is Germany-Argentina. This was the final. And if you scroll down, you're gonna see that is here, the last match. So 1-0, and it's here 1-0. So we successfully extracted all this data. And now what we have to do is put all this data into a table. And to do this in Python, what we have to do is use a library called pandas. Pandas is a package that allows us to better manage the data that we have. So basically in pandas, we work with data frames that is the equivalent of a table in Excel, but it helps us manage our data efficiently in Python. And to use pandas, what we have to do is import pandas. But first, of course, we need to install it. So we have to go to the terminal, write pip install pandas, and yeah, that's pretty much it. We press enter and we install pandas. So in this case, I'm going to import pandas as PD. So PD is going to represent pandas. And now to create a data frame, which is a table, basically is simply a table, what we have to do is create lists to build this data frame. So what I'm gonna do here is create 3 lists. One for the home team, the other for the score, and the last one for the away team. So I'm gonna write home equal to this empty list, and then here the score, then away, and that's it. Now I have to append each element to these lists. So I'm gonna delete this print one by one so I don't get any error. So it's ready. So now I'm gonna write home that append open parentheses, and with this we append each home team to the home list. And then we do the same with the score, and also we do the same with the away team. So away that append, then we open the parentheses, and that's it. So we have each element in each list. So with this, we have the lists. Now what we have to do is create a data frame. And something I like to do is first create a dictionary to organize my data, or my lists in this case. So I'm gonna create a dictionary called dic_football. And I'm gonna open these curly braces and write the keys. In this case, you can name it as you want. I'm gonna name it the same name I put for the list. So home, score, and away. And the values are gonna be the lists that we created. So the home list, which is this one, then the score list, which is this one, and finally the away lists. Again, these names can be different from the keys. And finally, what I'm gonna do is create a data frame. So I write PD, which represents pandas, that data frame. This is the method that we're gonna use. And then I'm gonna use this dictionary that I created, and I have it here. So with this, we create a data frame, and I'm gonna name it as df_football. So this is my football data frame. And finally, what I'm gonna do is also create a column that identifies the year of this data frame. For example, this is the World Cup 2014 from the Brazil. This World Cup belongs to Brazil, but we don't care about the country, but the year 2014. So to do that, to register that the year, we're gonna create a column named year. And then I'm gonna write it equal to, in this case, it's gonna be only for Brazil, and it's gonna be 2014, which represents the World Cup 2014 Brazil. So that's the final World Cup. And now I'm going to print so you can see the data frame. So I print this, then I right click and run, and we get this data. So we have all the data that we extracted better organized in a data frame. So we have from the first match, Brazil-Croatia, the year 2014, and the last match, Germany-Argentina, the final in 2014. So that's how we extract data from this Wikipedia website. But we only extracted one single World Cup, this 2014. But what we can also do is extract data from all the World Cups from 1930 to 2018. And then also we can extract the fixture of the 2022 World Cup. And to do this, I'm going to create a function. So what I'm going to do is first define a function which I'm going to name get_matches. And this is going to have as input the year. Because as you can see, the year is going to change. It's the only thing that changes. Then I'm going to put all of this inside this function. And then we have to identify another pattern. In web scraping, we always look for patterns most of the time. And here we have to see the website. So I'm going to the website again, and something interesting that Wikipedia has, this website in particular, is that it organizes let's say the links based on the World Cups based on the year. So this website remains the same, but the only thing that changes from, for example, the World Cup 2014 with the World Cup 2018 is the year. For example, if I write here, instead of 2014, if I write 2018 and press enter, voila, we have the World Cup 2018. And that works for all the World Cups, also for the 2022, which is the coming World Cup, Qatar. And also, for example, here, 1930, which is the first World Cup, we can also get it by just writing here instead of 2022, 1930. And we have the data of this World Cup. So now what we have to do is just implement this here in our code. And to do that, I'm gonna use something called fstring. Fstring is basically some kind of a string that allows us to put variables inside the string easily. So to do this, we only have to write the F in front of the quotes that we have here. And then we have to introduce a variable inside this string. We only need to write these curly braces. So now instead of writing 2014, we can write year. So this represents the input that I have here. So this is going to be for all the years that we have in this years list. And then we have to look for the changes that we have to make because we're now using that year variable. So everything here remains the same, and here we have another change. So instead of writing 2014, we have to write year, which represents my year input. And that's pretty much it. Now we can test this function by writing, but there is something else. Here I need to return something. So instead of printing this, I'm going to use return, and we're going to return this data frame, df_football. So this is the data frame, and finally we can test this function. So I can write the name of the function, get matches, and then we can write the year that we want. In this case, I'm going to write, 2018, which is the last World Cup. So 2018, and we can print this to see the results. So we print this, and now I'm gonna right click and then run this and see what happens. So we have the result. I scroll up, and we have from the first match, which was Russia, Saudi Arabia, 5-0, and the last match, France, Croatia, 4-2. So this is all the data in this World Cup, and as we can see, this function is working just fine. But there is a little detail I want to mention. There are some years, or actually some World Cups, where we don't have the same pattern. So for example, let's go to 1930. In this World Cup, actually it's here, 1930. If we inspect this website, we can see that we don't have the same pattern that we use here for the home score in a way. So for example, if we use the function and we extract data from 1930 and we press run, actually we don't get all the matches. I'm not sure if it was for 1930. I think it was for the World Cup 1982. I'm gonna run, and as you can see, we only have 4 matches, and this is very weird because in the World Cup 1982 there were more matches. So if we check out here, we see that there are a lot of matches, but we couldn't extract those matches because we don't have the same HTML document. So if we inspect this, we see something different for example, the home team. It doesn't have this this thing that we use, the fhome class name. It has a different class name and different tag name, I think. So what I'm trying to say is that for the old World Cups, we might not extract all the data, but we can use another approach that I'm gonna show you in the next video. So our function is working just fine, but for some years we cannot just extract all the data because they just don't follow the same pattern. But as I said before, we're gonna deal with that later in the next video actually. And now I'm going to finish this by extracting all the data of all these years. So what I'm gonna do is first use a for loop. So I'm gonna loop through this years list. So I write for year in years. And then I'm gonna use the function to get all this data. So get matches, and then I have to write the name of the year. Actually this year variable that is inside this loop. And we're gonna get all the data of all the World Cups. So now we need to store this inside another list. So to create this list easily, I'm going to use list comprehension, which is basically the same but with a different syntax. So I'm going to use get matches here. I'm going to put this here, and then I'm going to put this here. This might look weird if you don't know list comprehension, but it's exactly the same. But this helps me create a list faster. So here I can name the list, which is, I'm gonna name it FIFA, and this is basically the same. I can use this approach that I used here with home and empty list and then using append, but this is another approach that does exactly the same, but it's shorter, we can say. So after we do this, we get all the, we get one data frame for each year. So we get a data frame from 1930, 1934, and so on until 2018. So what we have to do next is concatenate each data frame. So we only have one data frame or one table. And when I say concatenate, I mean join all the tables. And to join all these tables, we have to use the concat method in pandas. So I write pd that concat to join all the data frames or all the tables of all the World Cups. So now I have to write FIFA because this is the list that has all the tables. And then I'm gonna add an extra parameter, which is ignore underscore index, and set it this equal to true. This basically ignores the index of each data frame, which is not absolutely necessary, but I just want to add it. Then I'm gonna write df underscore FIFA, which is gonna be the final data frame, which is a combination of all the data frames that we extracted here from 1930 to 2018. And finally, I'm gonna export this to Excel, actually to a CSV file. So I write to CSV, and then I'm gonna write a name for this file. In this case, I'm gonna name it as FIFA underscore World Cup underscore historical data.csv. We need to write the extension, and I'm gonna add a parameter which is index equal to false. This allows me avoid these index that are here. So for example, here I have the index 0, 1, 2, and 3. If I don't want to export this into the Excel file or the CSV file, I have to set index equal to false. So I only export the columns home, score, away, and year. So that's why I write index equal to false. And with this, we have all the historical data from 1930 to 2018. And finally, I'm gonna also get the fixture of 2022. So if we go here to 2022, we're gonna see that we have exactly the same structure, but we have a single small difference. Here we have the matches, but we don't have the results because the World Cup Qatar 2022 hasn't started actually. So we only have the home team, the away team, but we don't have the result of the match. So that's why this is gonna be only the fixture. We're gonna get instead of the score, we're gonna get match 1. So here I'm gonna write get matches, which is the name of my function, and then write the year 2022. So with this we get the fixture. So I'm gonna name it as df underscore fixture. So this is the fixture, and now I'm gonna export this as a CSV file. So I write 2 underscore CSV, and then I'm gonna name it something like this that I have here, but instead of historical data, I'm gonna name it underscore fixture. So that's CSV, and then index equal to false. So we don't export the index, and that's it. Now we can run to see all the results. So I'm gonna right click, run this script, and wait a couple seconds. Alright, the script finished running, and now we can open the files that we exported. This FIFA World Cup historical data and the fixture. You can open it with Excel. In this case, I'm using PyCharm, and I have a plugin that allows me to read these CSV files inside of PyCharm. So I have these two files, fixture and historical data, and I'm just gonna open this first one, historical data, and I have this this file. So this is the CSV file that I'm opening in PyCharm, and this letters NBSP is just something that the plugin doesn't read well, but actually this is this was extracted successfully. So we have all the matches from the first match in 1930 to the last match in 2018. So the final France-Croatia 4-2. Then we can also open up the fixture of the World Cup Qatar 2022. So we have the first match, which is gonna be Qatar-Ecuador, and the last match, which is gonna be the winner, winner 1 with winner 2. So this is the final match, and that's it. That's how we scrape data using Beautiful Soup. And in the next video, I'm gonna show you how to scrape the missing data that we couldn't scrape using Beautiful Soup, because we successfully scraped data from most World Cups. But there are some World Cups like 1982 where we couldn't scrape the data because it has a different pattern. So in the next video, I'm going to show you how to extract the missing data using Python and another library called Selenium. In this video, we're going to learn how to clean data using the Pandas library. So in the previous video, we scraped real-world data, and when we work with real-world data, sometimes we can have some missing data or some blank spaces in some words or anything that needs to be cleaned. And to do this, we're going to use Pandas and Python. Okay, to start with this tutorial, we need to have Pandas installed on our computer. So in case you don't have Pandas, you have to run pip install pandas on the terminal, or if you have Jupyter notebooks like me, you have to add this exclamation mark and then run this on this cell. Once you have Pandas, you can run this and import Pandas as PD. Then we're going to read 3 CSV files, and these 3 CSV files are the data that we scraped in the previous videos. So this, the first one, the World Cup underscore matches data, this one is from a video where we scrape the data from Wikipedia, and in this one we use Beautiful Soup. And well, this is the first one. Then we have the World Cup fixture, and we use Pandas to scrape this data. And finally, we have the World Cup missing data, which is the third one. And this one was like the complement for the first one, because when we scraped this Wikipedia with Beautiful Soup, we didn't extract all the data because of some inconsistencies in the website. So we have to scrape again with Selenium to complete the missing data. And well, this is the data set or the CSV file that we got. So now let's run this and let's have a look at these data sets very quickly. So here is the historical data. This has the data from the World Cup 1930 to the World Cup 2018. Then the missing data, which completes that the previous data frame, and then the fixture. And the fixture are all the games that are going to be played in the coming World Cup Qatar 2022. So these three data frames are going to help me predict the winner of the World Cup 2022. And before I do the prediction and run any model or anything we want, what we have to do first is clean the data. And this is the something we must do always in any data analysis or data science project. Okay, now let's start cleaning the df underscore fixture data frame. So this is the data frame, and if we have a look at this data frame, we see that everything looks fine. But if you check this in detail, this data frame, we're gonna see that the strings inside the home and away columns have some blank spaces. So this is not visible right now. It's very hard to see. But if you work with the data, as I did before making the video, you're gonna see that there are blank spaces. For example, we can have as an example the word Qatar, and then a blank space. And we don't want that. We want to clean this data. So what we're gonna do in this case is use the strip method. So we have to write df fixture home. We have to select the column, and then we have to use the str attribute, and then use the strip method as I mentioned before. And with this, we make sure that we delete the leading and trailing spaces, the blank spaces. So if we run this, we only get the words we're interested in, so only the name of the countries. And we do the same for the away team. And then to save these changes, I'm gonna do just equal to, and then update the values. So that's how you clean the df underscore fixture. So if I run now this, if I run this, you're gonna see that it looks the same, but actually we got rid of the trailing and leading spaces. So that's something we had to do. So the df underscore fixture is clean. So everything else is fine. So now let's continue with the df missing data, and let's clean this df missing data and then add it to the df historical data, because as I mentioned before, this historical data and missing data are the same. Both are the World Cup matches, but in the first one we couldn't extract all the World Cups. I think there are some World Cups missing, and these World Cups are considered in the missing data frame. So let's clean the missing data frame, and then let's add it to the historical data frame. So to do this, first, something that I want to show you is that this missing data has some null data, and this is why we have to clean it. So if I do df missing data home and then use the isNull method and then show this, we can see that there are 64 rows that have missing data. So it has the NaN value, which means not a number, and indicates that it is missing data. So to get rid of this missing data or this null data, what we have to do is use the drop NA method. And to do this, first I'm going to copy this, and then I'm gonna write drop NA. So I write drop NA, and now what I have to do is write in place equal to true to successfully drop the values and save the changes and update the data frame. So with this, we drop the NA values. So if I run this, let me comment this out, and now run this, we're gonna see that if we run this one again, the line of code that returns missing data, we're gonna see that now we don't have anything. So we got an empty table, and this indicates that we successfully dropped the missing data with this line of code. Okay, now let's continue this, and for the next step, I'm gonna concatenate, actually I'm gonna delete this one, and yeah, I'm gonna concatenate the data frame. So I'm going to add the missing data to my historical data. So now that this data frame is clean, I'm going to add it. And to do this, I'm going to use the concat method, and this method allows me to concat two data frames or more data frames. So here I'm going to write, where is it? It's df underscore missing data, and the other is df underscore historical underscore data. So it's here. Okay, now I'm gonna add one extra parameter, which is ignore underscore index, and I'm gonna set it to true. So I do this because I want to ignore the index of data frame 1 and data frame 2. So if data frame 1 has index from 1 to 100 and data frame 2 has index from 1 to 300, with this I'm ignoring these original indexes. So when I combine them, this is going to start from 0 to the end. So it's not going to consider the original indexes, and that's good. So now I'm going to concatenate, and the name I'm going to set for this concatenation is going to be historical data. So this is my final data frame. And now what I'm going to do is after combining these two data frames, I'm going to drop some potential duplicates that we could get. So maybe when we extracted again the data here, the missing data, we could have extracted also some data that was already included here. And this is not good because we don't want repetitive data. And to avoid that, to make sure everything is going to be fine, what we have to do is write this, the name of the data frame, which is the result of the concatenation. And then we have to write the drop duplicates method. So I'm not sure if there is duplicate values, but just in case, I'm going to use drop duplicates. Then I open parentheses in place equal to true. So with this, we drop the duplicates in the historical data column, data frame. Then what I'm going to do is sort this data frame by the year. So I write sort values. It allows me to sort a data frame by a year or by a column, in this case the year, and then I write in place equal to true. And finally, I'm going to show this data frame. So we're dropping the duplicates. First we're concatenating, then dropping the duplicates, and then sorting by the year. So I'm going to run all of this, and now we have this data frame. And now we see that this data frame is the final historical data frame after the concatenation. We don't have duplicates, and this data frame was sorted by the year. So it starts with the first World Cup 1930, and it ends with the last World Cup played so far, which is 2018. And great, so we successfully cleaned the missing data, and then we added it to the historical data. Okay, now let's continue cleaning DF historical data, because so far we only cleaned the missing data and then we added it to the historical data. But this historical data, the final data frame, is not clean. We have to make some modifications to clean it, and also we have to make some modifications to have it ready for the processing that we're going to do later. Before you run any machine learning or anything you want, this data frame has to be ready. And right now it's not ready because, for example, the score column has this numeric data, but it's not only numeric data. We have this hyphen in the middle, and this is not good when we want to process the data. Usually we only want numeric data and we don't want anything else. So we're going to get rid of this hyphen in the middle, and we're going to create two columns for the home for the goals score from the home team and the goals score from the away team. So let's do this. And first, what I'm going to do to clean this historical data is do something that is a bit particular in this project, but it's necessary. So I was exploring this data frame, and I found that this data frame, or actually in the World Cups, there was a match between Sweden and Austria that ended in a walkover. And this means that one team was not in the wasn't part of the match. So when one team doesn't play the match, doesn't want to play the match, or cannot play the match for some reason, this ends in a walkover. So it's like 3-0 for the team that was actually waiting for the other team in the stadium. And this is not something good, because I want to predict the winner of the World Cup based on goals. And if I say that one team has 3-0 without actually scoring those goals, doesn't help me. This doesn't help me predict the winner of the World Cup, because it's not like they deserve those 3 goals. So I'm gonna change this data. Actually, I'm gonna show it right now. So I'm gonna copy this one and show you much better what I mean. So I'm gonna copy and show you here. So I run this, and we have this match, Sweden Austria 1938, and this is not numeric data. This is another thing that is not good for us. So as you can see, score here in the column, we have numeric data for 1, for example, here, and for 2 here. But here we have W/O that stands for walkover, and this is not something good. We have to either change this to 3-0 or delete it. And in this case, I'm gonna delete this row. And to do this, first I'm gonna get the index. So here first I got this with the str contains, which allows me to get only the values that contain this particular word, in this case Sweden. And then once I got the row I want, I can use index. And this index gets the index of this of the whole thing. So when this condition is through, we're gonna get this index, and this is the index that we're gonna drop. So all of this is here, and I name this as delete_index, and we're gonna delete it right now. So to do this, I'm gonna use the drop method. So I write first the name of the data frame, and then I write drop. Then I open parentheses, and with drop we can drop either columns or rows. In this case, I'm going to drop a row, so I write index equal to and delete index. Then in place equal to true, and this is ready. So if we run this, we can see that this is not here anymore. So just to verify this, I'm going to copy and paste it, so we can verify that we actually dropped this row. So if I run this, we get this empty data frame, which indicates that this is not anymore. So great, we dropped this this match that wasn't good for my analysis. So now let's continue cleaning the rest of the data. Okay, now something that I want to show you is that some columns, like the score columns, actually only the score columns, not only has this this clean score that you see here, for example 4-1, but some of them have not only digits, but has some other things. For example, here I'm using this regex that stands for regular expression, that gets the matches that are not in the matches the characters not in brackets. So in this case, it's matching anything that is not a digit and that it's not this hyphen. So anything that is not a digit and is not a hyphen is not the score, right? Is maybe a text, maybe it's something else, but that's what we want to identify. So here I'm using the string contains, and let's find out what's not a digit and what's not a hyphen in our score column. So I run this. Now I need to add this one here to show, and okay, now we got this. So for some reason, some scores, as you can see here, have this parenthesis and then AET. I don't know what that means, but we don't want that. We only want the digit hyphen digit that represents the score. And to get rid of this, I'm going to use the replace method. So this method allows me to replace one string with another. And to do this, instead of writing here contains, I'm going to write the name of the column first, str, and then I'm going to write replace. So I'm going to replace this, which represents something that is not a digit and not a hyphen. So anything but digits and hyphens, so all of this in this example, and here all of this, and we're going to replace this with an empty string, which is this one. So after we do this, we're gonna turn on regex. So I write regex equal to true, and that's it. So with this, we replace anything that is a digit and hyphen with an empty space. So we can run this and see the results. So I'm gonna run, and now we can see that we replace these values successfully. So now what I'm gonna do is write this, and I set this equal to, the df historical data score, I set this equal to the expression we had before. And with this, we're updating all this column. So great. Now, if I run this, we shouldn't have those parentheses with A, ET anymore. Great. Now let's also clean the names of the words inside the home and away columns. So to do this, I'm just gonna copy this and I'm gonna strip this because it might have some data with blank spaces, and we have to get rid of the leading and trailing spaces. So what I'm gonna do is write this. Actually, I'm gonna do it below, and I'm gonna write it here, and actually here. And then what I'm gonna do is change the name. So instead of df underscore fixture, what I'm gonna write is this. So I can replace each of them and clean it easily. So if we run this, we can see that actually we won't be able to see it because, as I mentioned before, those blank spaces are kind of invisible. But now we have, we're certain that we don't have either leading or trailing spaces. So that's good because that can spoil our analysis. Okay, now next we have to split the score columns into home and away goals, and then drop the score column. So with this, we're gonna get rid of the hyphen in the middle, and we're gonna split the home, the goals scored from the home team and the goals scored from the away team. So this is just to have this data better organized and also have only numeric data. So I'm gonna do this, and to do this, I'm gonna use the split method. So I'm gonna write here first the name of the data frame, then the column I want to work with, then str, and then split. And inside, I'm gonna write this element, which is the hyphen, and then I'm splitting with a hyphen. And if I run this, we see that we get a list for each row, and this list represents only the elements that are numeric. So for example, 4.1 and 4.2, here 4.1 and 4.2. So we have a list with these two elements. And now if I want to put each element in a column, in a separate column, what I have to do is add expand equal to true. So with this, we get two columns and one data frame. So 4.1, 4.2, and this is what we wanted. Now, if we want to add this to the historical data frame, what we have to do is write this, the name of the data frame, and then specify the new names of the column. So I want to name the column 0 as home goals, and I want to name the column 1 as away goals. So that's it. That's everything we have to do. So if we run now this, we should get the two columns. So I'm gonna run this, and I'm gonna show you now the value here. So here's the value. We have this the home, score, away, and year as the original data frame, and then we have home goals and away goals, and this is what we wanted. So instead of 4-1, now we have 4 in one column and 1 in another column, and this helps us a lot when we want to do some processing later. So that's what we wanted. And now we have to get rid of the score column because we're not going to use it anymore. So I'm going to drop the score column using the drop method and writing here score, and then here setting axis equal to 1. So with axis equal to 1, we indicate that we want to drop a column. So you have to write axis equal to 1 for columns. Then in place equal to true, we run this, and if we have a look at the data frame, we'll see that we have now all the columns, but not the score column because we dropped it. Okay, now to continue this, let's rename the names of the columns here, home, away, and year. And also let's change the data types. So let's, I'm going to delete this and let's do this here. So let's rename the columns. And to do this, we have to use the rename method. And we have to write rename, then columns equal to, here columns because we want to rename columns. And then we have to write the original name on the left, and on the right, the new name. So instead of home, I want to name it as home team because this represents the home team. And then instead of away, I'm going to write away team. And the last one is going to be the year. So I'm going to write here year, and I'm going to write the first one in uppercase. So that's the year. And finally, in place equal to true to update this data frame. So in place equal to true, and that's it. Now I'm gonna change the data types because here, if we see again this data frame, apparently this the year, home goals and away goals have numeric data. I mean, the data type should be int, which is int, which stands for integer. But that might not be the case. If we check dtypes, which is an attribute that returns the data types, we'll see that only the year has integer values. So only the year has actually numeric values, that in this case is an integer. And home goals and away goals have object, and this represents strings. And we don't want strings. We want that home goals and away goals, we want them to be only integers, not object or strings. So what we have to do here is write this, and then we have to write as type. As type allows us to change the data type of any column we want. So now we open a dictionary and we specify any column we want. So we want to change home goals to int, then we want to change away goals, and it's going to be the same in this case, int integer, and then we could also set year to integer. We don't need to do that, but I just wrote it here, and well, that's it. So I'm going to add the in place equal to true to save these values. Or actually what I can do too here is just write df historical data equal to this, and with this we can also update the whole data frame. That's another way, instead of writing in place equal to true. So now I run this, and now if I show again this data frame, we see that we have these new columns, or actually these new column names. And then if we see the data types with the types, we'll see that now home goals and away goals are integers, and that's what we wanted. Okay, finally, we're going to create a new column named total goals. That's not necessary, but let's just create it in case we need it. So the total goals is going to be the home goals plus the away goals. And that's what we're doing right now. So away goals plus home goals. And this is going to be my total goals. So I write this equal to, and then I add a new column, which is total goals. So we run this, and I got an error because I didn't write here the square brackets. So now I run, and if I show you the data frame, we'll see that we have a new column named total goals, which represents the sum of these two columns here. Okay, that's it for the cleaning part. So we have now all our data cleaned, and to finish this, we have to export this clean data frame. So we have to export it to CSV files if we want it. So to do this, I'm gonna write first historical data. This is the last data frame we cleaned, and I'm gonna write to_CSV. And then we have to write the name of the data frame. In this case, I'm gonna use the original name, which was, let me see here, historical data. It was this one. And I'm just gonna add the word clean in front of that name. So clean_FIFA World Cup matches. And that's it. So now I can also add index equal to false. And with this, we're not going to export the indexes. In this case, 0, 17, 16, and so on. But we're going to export only the data inside these columns that I'm highlighting right now. And well, now let's continue with the fixture data frame, which is this one. And for the fixture, we have this name. So I'm going to add also the name. I'm going to use the same name, and I'm going to add the word clean in front. So I write clean underscore and now this name. So now I copy this and then I'm going to paste it below. So this is the name, and then I'm going to write here index equal to false. And with this, we're going to export these two data frames. And now I'm not exporting this data frame name missing data because we already included this data frame inside the historical data frame before when we concatenated these two data frames. So when we use the PD concat, we put them together and we actually put all of this in the data frame historical data. And well, if we run this and then we check our directory, I have it here. Now we see that we have two files, this clean FIFA World Cup picture and then clean FIFA World Cup matches. And that's it. That's how you clean data using pandas. And before I finish this video, I want to show you some practices that we often use to do some verifications. Sometimes we can verify if we successfully clean the data by checking the number of elements that we have, because by mistake we might have get rid of some rows, or maybe we didn't get rid of some rows that should have been deleted. And we could verify this using the len function, and in this case with the year, because we can verify how many matches we have per World Cup. If we run this, we can see each World Cup, each year, and then the number of matches, because I'm using the length of the data frame, and this returns the number of rows, so the number of matches. So if you know something about football, you will know that in 2018 there were 64 matches between among the group stage, the knockouts, the quarterfinal, semi-final, and the final. There were 64 matches. But this was not the case for the all World Cups. For example, 1994 had less matches. But if for some reason, for example, you got here in 2018 30 matches, you will see that you maybe by mistake dropped some rows here in 2018, because you should have 64 and you had, in the example, you had 30, for example. And that's something that could help you verify that you successfully clean your data. So that's something that you can do sometimes when it's possible. And this is something I recommend you always to do, to verify that the final data makes sense. So there are many ways to do this, and that depends on your data set and also on the information that you have available. And that's it. In this video, we cleaned the data we scraped in previous videos. Now that the data is clean, we can start making our predictions with Python. In this video, we're going to predict the winner of the World Cup Qatar 2022, and we're going to use Python for this. We're going to use the pandas library, and also we're going to use SciPy to import the Poisson distribution. So let's get started. Okay, to start with this video, we have first to import pandas, pickle, and the Poisson from SciPy. So to do this, first we have to install these libraries. So in case you don't have any of them, you have to write pip install and then either pandas or pickle or SciPy. So if you're in Jupyter Notebooks like me, you have to write this exclamation mark. And if you're on any other IDE, you have to open the terminal and run this command, pip install and the name of the library. Okay, once you have the libraries installed on your computer, we have to run this, and we successfully imported these libraries. Okay, now for this video, we're gonna use this CSV file. We're gonna import this CSV file and we're gonna read it with pandas. So let's have a look at the CSV files. First, we're gonna use the dig table. Actually, this dig table, I web scraped a website to get the tables of the groups in the World Cup, and then I exported these tables with Pickle. And now I'm reading this table again with Pickle. So all these files, this dig underscore table and these two CSV files are going to be in the description, and you can download. These files. Just for the record, we extracted this data in previous videos. So if you are interested in learning web scraping and how to extract this data on your own, you can watch those videos. But if you're not interested in that, you can just download these files, and these files has the clean data, and you can read it in with these lines of codes. Okay, so now then we have the clean FIFA World Cup matches, and basically this has the data from the World Cup 1930 to 2018. So we have all the historical data, all the matches played in those World Cups. And finally, we have the World Cup fixture. This is the fixture of the World Cup Qatar 2022. And now we can read all this data and have a look to this data. So I'm gonna show you first the dig table, and this one has the groups as I said before. So we have the tables, and right now it has only the value of 0 in each team, because we haven't run any model to predict who is going to be the winner between the matches that are going to be on the World Cup, but we're going to take care of that later. So we have here all the groups from group A to group H. Okay, then we have the historical data, as I said before, from the matches from 1930 to 2018. Okay, then the fixture of the 2022 World Cup, and this is the fixture. Okay, now let's see the next thing we have to do, and here we have to split the data frame historical data into two data frames, home and away. And to do this, first I'm going to show you again this data frame, and here we have this data with all the matches, and what we have to do is to split this into two. So we have to write, for example, df home, this is the one of the data frames, and this is going to be equal to df historical data, and then we have to select only some columns, and the columns that we're going to select are the home team, then the home goals, and then away goals. So 3 columns, and we're going to do the same for the other one, for the away team. So I write df away, and then away team, then home goals 2 and away goals, and that's it. So with this we have these two data frames, and we can run this. So we ran these lines of code, and then for the next step we're going to rename some columns. So I'm going to show you the name of this data frame, the content of this data frame actually, and this is the content. So we have the home team, home goals, and away goals. And now we're gonna rename some columns for some particular reason, and I'm gonna explain you right now. But first I'm gonna write rename, which is the method that allows me to rename a column, and then write the column parameter, or actually columns. Then I open a dictionary, and we can rename any column we want. In this case, we're going to rename the 3 columns that we have here. So first home team, and then home goals. So I'm going to write here first the original name, then this colon, and then the new name. So instead of home team, I just want to name it as team. Then we have home goals, and I want to name this as goals scored. So I don't care if it's from the home or the away. I just want to name it as home scored. Actually, goals scored, sorry. Goals scored. And for away goals, we're going to name this as goals conceded. So I'm going to open this quotes and then write goals conceded. So we have team for the home team, then goals scored, and then goals conceded. And this is basically because when the home team scores a goal, those are the goals they scored. And when the away team scores a goal for the home team, those are the goals that the home team concedes. So that's why I wrote here goals scored and goals conceded. So that's the reason why I'm writing this. Then we're gonna do the same for the away data frame, but in this case I'm gonna write df underscore away. Now rename, and here away team, so it's something like this. And then we're gonna use again team instead of away team. And then here there is something that you have to keep in mind. Now we have to be in the point of view of the away team because we're in the away data frame. So the home goals for the away team are like goals conceded. So I'm gonna write here goals conceded. So every time the home team scores a goal, for the away team, that's a goal conceded. And every time the away team scores a goal, for the away team is a goal scored. So this is kind of the opposite of the previous one, which was from a point of view of the home team. So this one was from the point of view of the home team, and the last one is from the point of view of the away team. And now we have a standard column names, and this is gonna help me for the next step. So here I'm gonna update these values by writing here df home equal to this, and df away df away equal to this. So with this we have some standard names for the columns, and now we can continue. So I'm gonna run this, and now what we're gonna do now is concatenate again the home and away. So we're gonna have again our historical something like our historical data, but now it has a different structure. So when we concatenate the home and the away data frames, we're gonna build the team strength, and basically this team strength is gonna be the foundation for this prediction. So I'm gonna show you here so you understand much better what I'm trying to say. So I use pd concat to concatenate 2 or more data frames, and then I'm gonna use df home here first and then df away. So these are my 2 data frames. Then I'm gonna add the ignore index parameter and set it equal to true because I want to ignore the original indexes from the 2 data frames. And then I'm gonna group by team, and after we group by team I want to get the mean, and we get the mean because I want to get the mean of the goals scored and the goals conceded, so we can see the strong points and the weak points of each team, or in this case each country. So this is what we're gonna do. So if I run this, now we can see that we have all the teams listed, or all the national teams listed, and we have the average of goals scored and goals conceded. And this is good because now we know how good is a team or how bad is a team. So for example, we can see here Argentina has 1.69 of average in goals scored and 1.14 in average for the goals conceded. So we can see that they score a good number of goals, but they don't concede so many goals. So this is gonna help us when we, for example, we have a match. I don't know. We have a match Argentina with Mexico. So based on the goals scored and the goals conceded, we can predict who is gonna be the winner. So this is our basic prediction that we're gonna do with Python and with the Poisson distribution that we're gonna see later. But for now is enough. So I'm gonna name this as df underscore team underscore strength. So I run this, and now, well, copy, paste, and now I run this. So I run, and well, we have this data frame, which is gonna be the base for my prediction. So now that we have this data frame with the goals scored and goals conceded, what we have to do is create a function that predicts how many points one team is gonna get. So we have 8 groups in the World Cup: Group A, B, C, D, until Group H. So in each group, we're gonna have many matches, and after one team wins a match, that team gets 3 points. If the match ends in a draw or a tie, each team gets 1 point, and if the team loses, the team gets 0 points. So we're gonna create a function that gives some points to each team based on this goals scored and goals conceded. So we're gonna do this here, and actually I already have the function because there is a lot of code here and I don't wanna build this from scratch, but I wanna explain you what this means step by step. Okay, to predict the winner of the World Cup Qatar 2022, we're gonna use the Poisson distribution, and well, we have to implement the Poisson distribution here in Python, and this is all the code. But before explaining you all this code and what each line of code means, what I'm gonna do is explain you about the Poisson distribution, why we're choosing the Poisson distribution, and the application that we can use in football. So that's more important because we can write code, but if we don't know what we're doing, we don't know the statistics or the math, we won't be able to understand how we're solving this problem. So let's check the foundation here, which is the Poisson distribution, and let's go here. So here's the Poisson distribution, and the Poisson distribution is a discrete probability distribution that describes the number of events occurring in a fixed time interval or region of opportunity. And if we apply this to football, we can consider a goal as an event that might happen in the 90 minutes of a football match. So a goal can happen in the 90 minutes of the match. We can have one goal, no goals, or 3 more or more goals. And that's our event. So this event happens in the 90 minutes of a football match. So this is a fixed time interval because a match has 90 minutes. We can have some extra time, like 3 more minutes or 5 more minutes, but we know for sure that every match at least will have 90 minutes. So that's the idea that we should keep in mind. Alright, now before we choose any distribution, we have to make sure that we're following the assumptions that these distributions have. So for the Poisson distribution, we have 4 main assumptions. And the first one is the number of events can be counted. And in this case, if we consider an event as a goal, then we can say that we can actually count the number of events because we can have 1 goal, 2 goals, 3 goals in a match, and we cannot have 1.5 goals or 3.5 goals. So we can say that we can count the number of events. In this case, we can count the number of goals. So number 1 is correct. Then we have the second one, and the second one says that the occurrence of events are independent. And this one also, our project follows this second assumption because the occurrence of one goal does not affect the probability of the occurrence of another goal. So we can say that 2 goals are independent. And well, in this case, it's arguable that that maybe if a team scores 1 goal, that can motivate the other team to go and score 1 goal. So the match will be 1-1, for example. So that's arguable. But to make things simple for this project, we're going to assume that 1 goal is independent from another goal. Okay, then we have number 3, and it says that the rate at which events occur is constant. And basically this means that the probability of an event occurring in a certain time interval should be exactly the same for every other time interval of the same length. And we can say that this one is also true because in a match, the probability of a goal in one match is the same probability of the goal in another match. So if we evaluate the probability of goal in different matches, we should have the same probability. So this one is also fine. And then we have the last one that says that two events cannot occur at exactly the same instant in time. And this one is also true, because in a football match, we cannot have two goals at the same second, at the same time. So we have one goal, and after, I don't know, 5 seconds or 10 seconds or 1 minute or 10 minutes, we have the second goal. But we cannot have two goals at the same time. That's impossible. So with this, we see that we successfully follow the 4 assumptions. And now let's see the Poisson distribution. So here's the equation of this Poisson distribution, and the main input is the lambda. So the lambda represents the expected number of events per time interval. And if we consider our project here, our football project, we can say that lambda is the median of goals in 90 minutes. So in this particular case, I'm gonna have 2 lambdas. Lambda for team A, or for the home team, and lambda for team B, or lambda for the away team. So we're gonna have 2 lambdas, and then we have the x, and the x represents the number of goals in a match that could be scored by team A, or the home team, or team B, also known as the away team. So a match, for example, can be like the final score 3-2, and we have the x for the team A, which is 3, and the x for team B, which is 2 in this example. Okay, now that this is clear, let's see how to implement this Poisson distribution equation in Python. So here I have the function that I created, and I'm going to explain you right now. But before this, to use the Poisson distribution, we have to import it here from SciPy, that's stats, and we import Poisson. So here we can use it, and actually I'm using here Poisson to calculate this equation. So instead of doing this equation manually, we use here the Poisson function. And okay, let's have a look at the function that I created, which I named predict_points. So this function is gonna get the name of the home team and the away team, and it's gonna return the points that each team receives. So now, after we define the input and output, here I have a condition. So I write if the home team is inside this data frame, df team strength, which is this one. If this home team is inside here in the index, and if the away team is also here in the index, then we can calculate the lambda for each team. And this is something that we have to keep in mind, because here the names have to be exactly the same as we have it here in the index. And we're not going to have any problem, because the names of the data frames, the different data frames, have the same name. I just mentioned this in case you want to try it yourself when you write it on your own, the name of the country. It has to be exactly the same as we have it here. Okay, now after this condition is true, we calculate the lambda. And as I mentioned before, we have 2 lambdas. 1 lambda for team A, or the home team, and 1 lambda for team B, or the away team. And the way we calculate the lambda might change. In my case, I did it in this way. I multiply the goals scored with the goals conceded. So this shows how it shows how many goals a match can have, and it's based on the goals scored and the goals conceded. So the goals scored by the home team, in this case home, and the goals conceded by the away team. So let's have a look at lambda home. So we select the from the team strength, which is this one, we select the goals scored. So this is the average. So here, as you might remember, we calculated the average goals scored and the average goals conceded. So we have the average goals scored by the home team, and we multiply this by the average goals conceded from the away team. So we multiply this and we get a value, and this value represents lambda. And the same goes for the away lambda away. So it's the same, but here we have away the goals scored by the away team and the goals conceded by the home team. So you can see that the more goals the team scores, it makes lambda bigger, and the more goals the other team concedes, it makes the lambda of the team, the first team, bigger too. So it's a way to benefit those teams that score more goals and to penalize those teams that concede more goals. And that's basically how we calculate lambda home and lambda away. Then I create three variables: the probability of home, then prob away, and then prob draw. And I set this equal to 0 to start from 0. And then here I do two for loops. So these are the simulation of the match. So I'm using a range from 0 to 10, and I'm saying that a match can have only between 0 to 10 goals, and I'm simulating each score. So for example, 0-0, 0-1, 0-2, 0-3, and then I'm doing the same with the opposite, with the now in benefit of the away team. So 1-0, 2-0, 3-0, 10-0, 1-1, and so on. So I'm calculating all the possible scores, and I'm using here the Poisson function to calculate here this equation. So I'm replacing lambda here with lambda home and lambda away, and then x is going to be here the number of goals. So x here, the number of goals of the home team, and y the number of goals of the away team. And that's how I calculate the probability. So I have P that represents the probability. And now then we have three scenarios. So we can have, based on the score, X and Y, we can have three scenarios. We can have a draw, we can have the winner, the home team, or the winner, the away team. So those are three scenarios. That only three scenarios that can happen in football. So if we have a draw, so if the score is, for example, 1-1, then we're gonna accumulate the probability. So here we have the probability that we calculated, and this probability is gonna be added only to the scenario that it corresponds. So if the score here is x1 and y1, then x is equal to y, and then the probability of draw is going to be this p. But if, for example, the score is 1-0, then x is greater than y, then the p is going to be equal to probability of home. And finally, if the x is less than y, for example, we can have 0-3, then we're gonna this p is gonna be equal to the probability of away, and this is gonna be accumulating for each simulation. So we're gonna add we're gonna simulate each score, and then we're gonna add to the scenario that it corresponds, and that's how we're gonna get the final prob underscore draw, prob underscore home, and prob underscore away. And with this, I created here a formula to find the points home and the points away. And this formula is easy to understand if you think of a scenario where the probability of home is 100% or 1. If this is 100%, then the home team wins, and then 3 multiplied by 1 is 3. And then if this is 1, so if the probability of home is 100%, then the probability of draw and the probability of away is going to be 0. So 3 multiplied with 1 is 3, then plus 0 is 3. So we have that the points of the home team is 3. And that makes sense, because when a team wins a match in football, they get 3 points. When it's a draw, they get 1 point, but when the team loses the match, they get 0 points. So this makes sense. And in case of the probability of draw being 100%, then we have here 1, and then this one is going to be 0, the probability of home. So 3 multiplied by 0 is 0, and then we have here the points home 1. And again, makes sense because when it's a draw, then we only get 1 point. And the same goes for the points away. It's the same idea. So here, after we calculate the points home and the points away, we return this inside the tuple. So this tuple has the points home and the points away. And in case this condition is not true, so this one is false, then we're gonna return here a tuple that has only the values 0 and 0. And this might happen even with our data that is correct. So I'm gonna explain you why. But to explain you why, I'm gonna do some examples here. I'm gonna test this function. So here I'm gonna run this, and now let's see why we sometimes might get 0 and 0. Actually, it's not sometimes, it's only once for one particular team or country. So let's test our function first, and then I'm gonna explain you. So by testing our function, we also will see what this function means. So we can write predict underscore points, and then let's write the first team, which is Argentina and Mexico. They are in the same group, so it makes sense that I run this. So I run, and now we get this output. And what this means is that if Argentina plays with Mexico, then Argentina will get 2.3 points and Mexico 0.5. So there are 3 points available. That's the maximum number of points a team can get. And if Argentina plays with Mexico, from those 3 points, Argentina will get 2.3 and Mexico only 0.5. And besides the points, that also represents how powerful is a team compared with another team. So that's another way to say it. And now let's see another example. So in this case, I'm gonna write England and United States. So that's another match that I think is in group B or in another group, I don't know. Then we have the result, and it says that if England plays with the United States, then England has more chances of winning the 3 points than the United States. So now let's have a look now with Qatar and Ecuador, which is the first match in the World Cup. And here we're gonna see something interesting. So let's write Qatar and Ecuador and now run this. So if we run this, we get 0,0. And this happens because here Qatar is the only team in the World Cup that is participating for the first time. So we don't have historical data of Qatar in the World Cup. So that's why we cannot find Qatar in our DF team strength data frame. So here in our index, we don't have Qatar because it's first time in the World Cup. So we cannot create data or use some friendly matches to include it here in this data, because it won't be the same matches played in the World Cup with friendly matches or with any other competition. So that's why I thought that much better is just to ignore Qatar. So Qatar is going to be the only country or the only team that is going to be ignored in this analysis. So any team in the group stage that plays with Qatar, both teams are going to get 0. So for example, Qatar, Ecuador, both get 0, and the other teams are going to get 0 too. So in this case, the only team affected is going to be Qatar, but the other 3 teams are not going to be affected. So now, with that clear, we're going to continue with the prediction. Okay, now we're going to start with the prediction. And to do this, first we have to split our fixture. So here we have the df underscore fixture that we haven't used so far, but we're going to start using to make our predictions. So first I'm creating different data frames, and I'm splitting this into the group stage that has 48 matches, then the knockouts, the quarterfinals, semifinal, and the final. And this helps me better organize all of this data. So I'm gonna run this, and by the way, I'm using the copy method to create an independent copy. So I run this, and now we have these data frames. For example, here we can see the 48 matches if I run here. So the first one is Qatar with Ecuador, and the last one is gonna be, let me see here, Cameroon with Brazil. So those are all the matches. Great. Now let's continue here, and now we have to run all the matches in the group stage and update the group tables. So we're gonna simulate all the matches that are gonna be played in the group stage, which is here. So all the 48 matches are gonna be simulated here below. And to do this, I just copied and pasted the code that we're gonna use, because there are a lot of code and it's gonna take me a lot of time to explain you this from scratch. But I'm gonna explain you right now what it means line by line. Okay, first here, I'm doing a for loop here in the dictable dictionary. So as you might remember, this dictionary has all the tables of the World Cup. So I can do here a keys to see all the keys. And now if I select a group, you can see that we have the tables. So let me show you here. And here we have the tables. So now we have all the teams, they have 0 points because we haven't simulated the matches. But now let's simulate it. And to do this, first, we have to get the names of each group. I mean, the names of the team of each group. So to do this, we have to write the name of the group, and then we have to select only the column we want. In this case, the team name, or the team column, sorry. We have to select the team column, and then with the dot values, we're gonna get the team names. So if I print this, let me print it. We're gonna see that we get the names of the team separated by groups. So for example, group A has Qatar, Ecuador, Senegal, and Netherlands. Then we have group B, group C, and so on. So now we have the names of the team separated by groups. And then we're selecting these groups, or actually we're selecting these 4 teams from our 48 matches. So here we have the 48 matches, and we're using here the is-in method to filter only those 4 teams. And why I do that? Because I want to get only the 6 matches that every group has. So every group has, for example, group A has 4 teams, and these 4 teams in total have 6 matches. So we have a match between team 1 and team 2, then team 1 and team 3, then team 1 and 3 4, that's 3 matches, then team 2 and team 3, that's 4, then team 2 and team 4, that's 5 matches, and finally team 3 and team 4, those are 6 matches. So every team is going to play 6 matches, and I want to separate them. So that's why I create this df underscore fixture underscore group 6. So that represents the 6 matches that each group has to play. And then I use the iter rows to iterate through each row in this new data frame that only has the 6 matches. And then I choose the home team and the away team. So right now I have the right matches in each group, and I can make my prediction. So I do all of this just to avoid making some unnecessary simulations, because for example, we cannot make we cannot have a match between Argentina and France, because Argentina and France are not in the same group. So it's impossible in the group stage to have a match between Argentina and France. So if I split this into groups and only have the matches that are going to happen inside each group, then I can just simulate those matches that are going to happen in reality. So with this, I have the prediction, the predict underscore points function, and then I write the home team and the away team. Then I get the points of each for each team, and then we can add the points in the table. So here we use the dig table, and we use the log method to locate the home team and also the away team. And we also locate the PTS column that stands for points, and we add the points of the home team to this value, which right now is 0, and we add also the points of the away team of this value, which is 0 too. And we do that for every match that is gonna be played. So after that, we're gonna do some little changes to the final table. So first we're gonna sort values by points, by the points column, and then we're gonna sort it in descending order. So ascending equal to false. And then we're gonna select only the team and the points column. Then we round to 0, and I do this to have integer points. So we don't have here, for example, if I comment this out, you can see this. So we don't get 2.23, but we get only 2. And here we don't get 0.59, but we get probably 1. So we get integer numbers, because it's very weird to find a team that has like 1.3 points, because that doesn't happen in reality. So with this, we have our final table, and now I can run this. So if I run this, we successfully simulated all the matches in the group stage. So now I can show you each table. So we're gonna see the final table for each group. So I write dig table, then group A, and we can see that in group A, the Netherlands and Senegal are going to be the first and the second respectively, the second teams in this group. So now if we write group H, we see that Portugal and Uruguay both make it to the next stage, which is the knockouts, and we can check every table one by one if we want. But now what I'm gonna do is check out the knockouts, the knockout stage. So here I'm gonna run here df fixture underscore knockout, and as you might remember, we created this before here from our fixture data frame. And I run this because here we have to update the winner of the group, so the first team, and the runners up, so the team that was in second place. And we get these values from our dictionary, because our dictionary right now has the final table for each group. So we have, for example, for group C, we have that Argentina is going to be the winner of the group Z, winner of group Z, and then Poland is going to be the runners up. In this case, Poland runners up of group C is here. So we have it here. So we're going to update the values of the knockout data frame using the final results in the dig underscore table. Okay, now to update this table, we're going to do a for loop here. So we're going to loop over the dig underscore table. So I have this table, and this is a dictionary. So I'm gonna write for group in dig table, and then we can get each table here. And we want that because we want to get the winner and the runners up. So I write dig table, then group, and we can locate the winner, which has index 0. As you can see here, the winner has index 0 and the runners up with index 1. So we have to locate also the name of the column, which is team. And with this, we have, for example, in this case, log 0 and team. We go to 0 and column team. We have Argentina in this example. And we do the same for the second one. But first, I'm going to write here group underscore winner. Then copy and paste it here. And in this case, it's going to be runners up. So I'm going to copy this and I'm going to paste it here. So now underscore and R. So now we have this, but in this case, it's not going to be 0, but 1. So 1 represents the team that ended in position 2. So here we have 1 and then team. And in this case, we will have, for example, Poland in this example. So now we can continue, and let's let's continue by replacing the names here. Instead of having winners group A or winners group C, now I want Argentina in this example for group C, for example. So to do this, I'm going to write the name of this data frame. I press enter, and then I use the replace method. So I open a dictionary now, and I'm going to write, for example, here, winners group C. So this is the string I want to replace. And now the variable that I want to replace with, so group winner. And now I press comma, and we do the same for the runner up, in this case runner up group C. And now I'm going to replace this with the runners up variable. So that's it. Then I write in place equal to true, and that's pretty much it. But with this, we're only replacing one row. In this case, winner group C and runners up group C. So 2 rows. And that's not something we want. We want to replace all of them. And to do this, we have to add the F string. So the F string allows us to include a variable inside a string. So instead of writing group C, here we can write group. And the same goes for this one. We can write group. So with this, we're gonna replace all the values that you can see here that has the words winners or runners up. And that's it. Now to finish this, after we update all of the values, I'm gonna create a new column. And in this column, I'm gonna name it first as winner. And in this column, I'm gonna set this column equal to question mark. And this question mark represents that we don't know who is the winner of this match. So we don't know the winner of the match, and that's why we write this question mark. And now I'm going to show you this. So I'm going to run this code, and now we have the DF knockouts updated. So we have all the values here, for example, Netherlands, Wales, Argentina, who was the winner of Group C, with the runners-up of Group D. So we can check it out just to verify if everything is okay. And we see that the runners-up is Denmark. And yeah, it's Argentina, Denmark. So we have all the values here updated. But here in the winner column, we still don't know who is gonna be the winner. And to do this, to know the winner of this match, we're gonna create another function. And this function is gonna be based on the previous one that we had here, which was the predict points. But instead of having now the points of the home team and away team, this new function is just going to return the name of the winner, either the home team or the away team, but not point anymore. So we're gonna see the winner. So now I scroll down, and here is the function that we're going to create. And now let's create this function. So I'm gonna name this function as get underscore winner. And then I'm gonna write the name of the input. In this case, this function is gonna receive a data frame named df underscore fixture updated. So basically this is the fixture updated. For example, here, this is the fixture updated for the knockout. And well, we have this data and we have this question mark for the winner column. So this is the name of the input. And now we're gonna do a for loop inside the fixture updated. So we write for I in df underscore fixture updated, and we're gonna use the either rows. So we're gonna loop through each row inside the data frame. Then I write the colon, and now here instead of I, now we have two values, the index and the row. And now we can get the name of the home team and away team using the row that we have here. So we write row home, then we add the comma and row away. And that's it. Now we can have we can assign this to a variable named home and away. And now that we know the names of the teams that are gonna play, we can use the predict function that we created before. So is this one. Let me copy the name, so it's predict points, and we can use it here in our new function. So I write predict points, and we have the name of the home and the away team. So as you might remember, this function returns the points of the home team and the points of the away team. And now that we know the points of each team, now we can make a condition so we decide who is going to be the winner. So I write if point home is bigger than points away, then create a variable winner and set this equal to home. So if the points of the home team is greater than the away team, then the winner is going to be the home team. However, if that doesn't happen and the points home is less than the points away, then the winner is going to be the away team. And that's it. So with this, we calculate if the winner is the home team or the away team. Then we have to update this. So we write df fixture underscore updated. And then we use the log function. So we write here index because we have the index of that row. As you might remember, we're using the either rows. And then we locate the winner column. So this column that has the question mark. And we're going to replace the question mark with the name of the winner that we have it here. And that's it. Now we can return. So I write here return. And now I write the name of the df fixture updated. And that's pretty much it. Now with this we can calculate the winner. I run this and now we can get the winner of these knockouts. And we only have to write get winner, open parentheses, and then write the name of the data frame, df fixture knockout. So we run this and now we can see the winners of each match. So we can see, for example, that England will win the match against Senegal and Brazil will win the match against Uruguay. So that's how we calculate the winners. And now to continue with the predictions, we have to go to the quarterfinals. So we have the winners of the knockouts and now we continue with the quarterfinals. And now we have to update the table that has the quarterfinals, because here if I write I don't remember the name of this data frame, so I'm just gonna copy df underscore fixture underscore quarter. So if we run this, we're gonna see that we still don't have the names of each team. We only have winner match 53, which in this case is gonna be Germany, and winner match 54, which is Brazil, but we don't have this table updated. So we have to create a function to update the tables. And I have this function here. So I'm not gonna write this from scratch, but I'm gonna explain you what this means line by line. Okay, I named this function update underscore table. And this function has two inputs, the fixture of the round 1 and the fixture of a round 2. So basically this is like the just to give an example, this is like the fixture of the knockouts, and this is the fixture of the quarterfinals. Then we'll have the in the next stage we'll have like the fixture of the quarterfinals on the left for number 1 and the fixture of the semifinals for number 2. And for the next one is going to be the fixture of the semifinals for number 1 and the fixture of the final for number 2. So that's how we can update the table based on the results of the previous stage. Okay, now that this is clear, what we have to do is do a for loop in this fixture of round 1. So we use the either rows again, and now we get the winner of the match. So we use the log method and we get the winner. And then we also get the name of the match, because as you can see here, we need to know who is the winner of match 53 or 55. So we need to know the identifier, and the identifier is in the score column. So the score tells us the number of the match 58, 57, 60, and so on. So that's why we get it here. And after we get the winner and the number of the match, what we have to do is in the fixture of round 2, we have to use the replace method. So we're going to replace anything that says winner with any match, 55 or 56, and we're going to replace this with the actual winner, so the variable that we have here. Then we set here in place equal to true to update the changes, and we again create a winner column, and we set this equal to question mark, and then we return this final fixture, so with the data updated. So this is the updated table, and we're gonna run this, and now we have the fixture updated, but now we need to apply it to the quarterfinal, and we have to write here the fixture of the knockout. So if we write here round 1, which is knockout, and then we write here round 2, which is quarterfinal, I'm gonna copy here, so I have quarter. So if we write here knockout on the left and quarter on the right, and we run this, now we have that I got an error because I didn't write the name of the function. So here is the name of the function, and then fixture knockout, fixture quarter, run again, and now we have the fixture of the quarterfinal updated. So we have the matches. We know now that Germany is going to play with Brazil, Netherlands with Argentina, Spain with Portugal, and England, France. And now we need to know the winners. So we can use the get winner function to get the winners. So here I write get winner, I write fixture quarter, and we're going to replace the question mark with the actual winner of this match between Germany and Brazil, for example. If we run this, we now know that Brazil is gonna win the match, then Netherlands, then Portugal, and France. So now let's predict the results for the semifinal. And to do this, I'm going to copy here and this one too. So first we update the table. In this case, it's gonna be quarter for the first input, and for the second is gonna be the semifinal, which I believe it's only semi. Just in case, I'm gonna check this out. Yeah, semi, and the last one is final. So here is semi, and I'm going to run this for the semi-final. And now we know that the match is gonna be between the Netherlands and Brazil, and then France with Portugal. And now if we want to know the winners, we run this, and actually I left this fixture quarter. It should be fixture semi or semi-final. I run, and now we know that the winner between Brazil and the Netherlands is going to be Brazil, and between France and Portugal is going to be France. So now let's do this one more time for the final. So it's the moment of truth. Now we can see who is going to win the World Cup. So here I write the fixture semi, and then the fixture final. So the final is going to be between Brazil and France. I couldn't update the match between the losers of the semifinals, but that's not actually important. We only want to predict the winner of the World Cup, so this is not so important. The important thing here is the match between Brazil and France. This is going to be the final. After writing many lines of codes and implementing the Poisson distribution and many things, we're going to know now the winner of the World Cup Qatar 2022. So here I'm going to run get winner, and inside df fixture underscore final. So this is my function, and I'm going to run this. So after we run, we see that the winner is going to be Brazil. So Brazil is going to win France and is going to win its 6th World Cup. So according to all the Poisson distribution and all the Python code that we wrote, Brazil is gonna win this World Cup. And that's it. So now we finish this project, and this whole project is actually a real world project that is going to help you deal with other advanced projects. So now you know how to extract data from websites using web scraping, how to clean data, also how to visualize the data, and how to create a basic model that can help you predict something like a football match. So now it's time for you to implement everything that you learned into your own project. And that's gonna be a challenge for you. So good luck and congratulations on finishing this project.